So the question is, we have given an array which is named as a fruits, just like 1 to 1, and what is given in the question that you have two buckets, you have two baskets here, and you can put one type of fruit in the one basket here. Okay, and there's no limiter of whatever the number of fruits you can put on the basket. So you have to return what is the maximum number of fruits you can pick from there. Let's say when we talk about this test case 1 to 1, so you have one basket here and you have one basket here, so you can put the fruit number of type 1 in one basket and fruit number of type 2 in one basket, so we can pick up all the fruits. So the answer is 3. Again for the this test case, let's say I'm go to for the compiler and now check. There's a so this is my test case, and so let's say here is our basket number 1 and here is our basket number 2. So we can put, let's say if we start from this at our from indexing number 0, so if we here put fruit number of type 0 and here fruit number of type 1. Okay, now if when we go to 2, so we can't put in this type because 0 is already filled there and 0 is different from 2, and similarly here 1 is already filled, so we can't put 2. So the fruits, what how many of fruits we can fill there, so we put only 0 and 1. So this is we can go forward to checking whether there any possibility to putting many number of fruits there. So okay, so now start from there. Let's say if we put there 1 there. Okay, so I put 1 there. Now we go to this. Now can we put 2 here? Okay, 2 here. Now now for going to index number 3, now can we put 2 there? No, but 2 there here, yeah, so 2 here. So the how many numbers we can put there, so it should be the output is through 3, means we can put a maximum number of 3 types of fruit in this question. Let's say we go for the another test case. So here is, let's say this. Okay, so this is our test case. So let's say I'm drawing this. Here is our bucket 1, here is our bucket 2. Now starting from the index number 0, if we put here 1, okay, so now for index number 1 we putting 2 here. Okay, and now index number 2, here is a 3, but we can't put 3 here and we also can't put 3 here. So here's what is the maximum number of fruits we can pick there, so only 2. Okay, now checking move forwardly whether we can move, whether we can see more fruits. Okay, now if we starting from here, let's say just revisit this. Okay, now if we start from there, we can let's say put 2 here. Okay, now we 3 the for this 3 we can't put here, but this bucket is empty, so okay, put there. Now 2 here, so we can put. Okay, now for this 2 we can put here also. So what is the maximum number of fruits we can pick here? 4 number. Okay, so you have to picking the fruits in such a manner so that we can maximize that the number of fruits there. But okay, so the very we see one thing. So very first thing that we comes to see, we generally one of the brute forces that we have to generally traverse from I is equal to 0 to n, means we put here, and now j equal to 0 to n, like we have to traverse, we have to seek for all of the, actually what's the question that ask you from here. So you simply ask, basically I think we can short this question, like it is asking what is the largest sub array, because it is asking continuous. Okay, so largest continuous sub array possible with at most 2 unique fruits. Okay, so yeah, so basically this question is nothing, this fruit picking question is nothing but this, we have to find the such number of largest subarray, we have to return the length of the largest subarray such that only at most 2 unique fruit here. So the brute force is if we have to generate all of the sub-arrays then checking it, but you know very well that for the generating all of the sub-arrays it take of n square, but see here the constant is 10 power 5, so it gives a TLD, so brute force doesn't work. So we should go for the most optimal approach here. So we see one thing, like how we optimize this, because when we do generate we simply go for the loop I plus plus, and now we initialize our second pointer after this I, j is equal to I plus 1, and this goes so on. And now for each of the subarray we like see whether there's a how many type of unique fruits there. If the one is the twos is still okay. If we find the number of unique fruits is more than 2, so we don't go for this subarray, we have to find in another subarray, but we have to optimize this thing. So we think here like we use two pointer, okay, I0, and we initialize what we do here in the brute force. We generally moving our I pointer here, and we initialize j pointer after I. So what we go there, like when I'm talking about this test case, so what we see here, like when we start from this I, let's say this is our I, when we put we are talking about this subarray, okay, this is very well okay, but now when we about this subarray, so we see there is a there's a unique element, or there's a unique fruit is exceed 2. So what we do here, we generally remove everywhere, like we remove this subarray, and now we again initialize with this index. Similarly thing we again doing. So like can we optimize this thing, like we still use the two pointer, but in such manner that we don't have to revisit every time. So what's the most optimal way here? So because since this is a two pointer, so this should seem it suggests that we should go for the sliding window, because we have to find that continuous window. So we have a advantage in the sliding window that we can expand it and we can shrink it according to our use. So there's a no operations again operation required to revisit, again operation required to reset it. So we simply expand it, otherwise we shrink it, like whenever there is a unique fruit is below 2 or less than equal to 2, so we expand it till then it exceeds the 2, and if it exceeds 2 we shrink it till then it is again come in the range like 0 to 2. Okay, so it's nothing that we are our the target is we have to find the basically largest subarray, or we can say the window, we can say, because it is continuous. So what is the largest possible window which just contains at most 2 unique fruit here? So like this we so our question is turned into this. So we go for the sliding window approach. So okay, we initialize our I equal to 0 and j equal to 0. Okay, and also this is our count variable also. Now the traditional template of the sliding window, like we have to go until our end pointer, or we can say the j pointer, is exceeding over the size. Okay, so yeah, there's a one thing also ki, how we recognize how many of the number of unique fruit there. So for this unique fruit we can use many of the things, like we can use set, we can use order map. So what is the most optimal use? So we go for the unordered fruit, because to erase it or to push in it, it takes a very less time, so we use unordered map there. So there's int. Okay, so now, so for the whenever we have to stand at j, we simply put it, we insert it. Okay, now we see thing, like we check condition, if map of size is less than equal to 2, so we don't have to worry about it. It means we can update our answer. So we can count is maximum of count of this j minus I plus 1. Okay, the second condition is whenever the map size is exceeding 2, means in this map there's a the unique fruit is exceeding 2, it is greater than 2. So what in this, first of all we have to like shrink this, so we have to remove that I portion. Okay, And we can check if like mpp of view5 is equal to 0, means we have to remove it. So mpp dot delete, we use delete operation here, and it is view5, and simply and then I plus plus. Okay, and for the each of operation, like how this goes on, we simply increasing our j plus plus. So this so okay, so it gave me the C out, and we can count it and then okay. So let's say we have to check for this array. So what's the size here, and what's the array 1 2 and then 3 then 2 then 2. Okay, now run for this, whether is it working or not. What's the issue? Okay. First of all, I initialize the map with the name mpp, but I use here. Why doesn't work mpp dot delete? I think we can go for mpp of it is only. mpp. Okay, so it gives the answer for. Again, we can check for the another test case. Let's say we have this, like we have to the size is 4 and this 0, this 1, this 2, this 2. So it should give the output as a 3. Okay, so this is correct also. So yeah, so the code is working right. And what is the time complexity in here? The time complexity is, since we use one traversing only. Okay, so this, and what's the space complexity is, it's often this time complexity is often, and space complexity is also of often, because we use unordered map initialization here. And time complexity, why? Because this j scopes j loop, due to this the time complexity is often. Okay, thank